Hello, everyone. This episode of the On Orbit podcast is episode 2 of the Future Space Economy webcast via Satellite's webcast on future space applications beyond satellite telecommunications. Before we get started with the episode, I wanted to let all of you know that the Satellite 2025 conference application process for speakers has begun. We've launched our call for proposals for speaking applications on our website at www.satshow.com, and we will be accepting applications for speakers through August 1st. So please get your submissions and your applications in. We have a lot of really exciting new programs happening at Satellite 2025. We have the launch of the new GovMil Space Summit at Satellite. It's a new and expanded standalone event program held during Satellite for government and military satellite and space service providers and end users. We'll be focusing on how industry can support critical missions for the United States and its global military allies, with 16 sessions planned during the week, a dedicated pavilion on the show floor, and unique networking events. The GovMil Space Summit provides an incredible opportunity for government and commercial industry leaders to engage in insightful discussion and debate on a broad range of space technologies and services. So that's just one of the new programs that we'll be launching at Satellite this year. I'll talk about more in future episodes. But for now, sit back and enjoy this conversation on the future of commercial space stations. Hello, everyone, and welcome to this episode of Via Satellite's Future Space Economy webcast. My name is Jeffrey Hill. I'm Executive Editor of Via Satellite and Executive Chair of the Satellite Show. Thank you all so much for joining us. Today's episode is exploring NASA's Post-ISS space station options, or exploring the Post-ISS space station options for all of us. With the approaching retirement of the ISS, NASA has contracted several commercial companies to develop orbital facilities that will fulfill the need for a wide range of research and business activities in space. And we're going to be talking about those different commercially produced space stations, as well as how they're built, some approaches, some alternatives. We're going to be looking at some of the three that NASA contracted, and we're also going to be talking about some other platforms as well. We're going to talk about design approaches, compare and contrast deployment schedules, recent current events that'll impact those schedules, program costs, capabilities, in a discussion that maps out commercial space industry opportunities in a post-ISS world. And we have three fantastic speakers for our panel today, and we'll get to know them in just a minute. But before we start, I want to let all of you know that the Future Space Economy webcast is educational in nature. We put this on for you to educate you about these technologies. So we want you to be part of the conversation. If you have a question for our speakers at any time, we encourage you to submit that to us using the Q&A tab on the right-hand side of your screen on the interface. Those questions will come to us, and I can ask those questions for you. I'll keep your name and your company anonymous. So feel free to ask whatever question you need to. We'll weave those into the discussion as they're relevant. I don't like to wait until the very end. So ask those questions at any time. We'll try to get to as many as we can in the time. If we don't get to your questions, we'll try to get one of our speakers maybe answer those questions for you offline after the webcast. So before we start, I'd like to thank our sponsor, Kepler Communications. They're building the internet for space, which we can't really do anything without the internet, let alone in space. So thank you to them for supporting this webcast and the platform. So without further ado, I want to introduce our speakers. First, we have Jeff Manbear. He's president of International and Space Stations at Voyager Space. We're very, very grateful to have him here. He's been working with space station technology for a very long time and is very knowledgeable of these topics. He also serves as chairman of the board for NanoRacks. As CEO of NanoRacks, he oversaw the growth of numerous commercial ISS programs. In 1991, he negotiated and executed the first commercial contract between NASA and the NPO Energia in the Soviet Union to use the Soyuz crewed capsule as an escape vehicle for space station Freedom. So, Jeff, thank you so much for being with us. What brought you to Voyager Space through NanoRacks?
Well, I founded one of the founders of NanoRacks, which we grew into the largest user of the commercial user of the International Space Station. And I kind of knew at a certain point a few years ago I had reached my limit. We developed the Bishop Airlock, the largest commercial piece of hardware in use on the ISS. I felt we were entering, as we'll talk about, the era of private space stations. I had a good feeling that NanoRacks would be one of the winners because of all the work we put in on the whole public-private partnership and the right role with NASA. And so when I looked around the terrain, I realized that I thought the right mix of financial intelligence, to say, and they were acquiring interesting companies. So I sold NanoRacks to Voyager, and I stuck around. I don't know why, but I stuck around. So I'm continue. I want to see us move, as we'll talk about today with Mike and Dave. I want to see us move into this new era of commercial space stations and all that means. So I'm enjoying it.
Thank you so much, Jeff. I appreciate you being here. Next, we have Mike Greenlee, CEO of MDA Space, which, along being a legacy Canadian space technology company, has also long contributed to the ISS, developing the Canadarm family of robotics. Mike took MDA Space public in 2021. He's championed an ambitious strategy to shape MDA Space into a highly competitive pure-play space company focused on next-gen commercial space technologies like what we're talking about today. But just 2 weeks ago, MDA Space announced it was joining the Starlab space joint venture to contribute to building the Starlab commercial space station. So Mike, first of all, and also Mike was the most recent winner of our VIA Satellite Executive of the Year award. So Mike, wanted to say congratulations for your success this year. Thank you for being here with us. Tell us a little bit about what brought MDA into the commercial space station JV with Starlab Space.
Well, thanks for that. Thanks for the introduction. As it relates to space stations, MDA Space, as you mentioned, has a strong legacy in external robotics, especially having delivered the Canadarm series of robotics for shuttle and the 100 missions that were flown there, and then Canadarm2 and Dexter Technologies that were have had 25 years now on ISS with, I guess, 4 or 5 years to go. We've managed to commercialize all that now into a commercial line of robotics we call MDA Skymaker. And so we're really interested in working with commercial space stations to provide external robotics and the operation of them. And so we talk to all kinds of parties about the ability for us to do that on space stations and other commercial business models that'll require on-orbit robotics. Starlab was a great fit. The design of the station calls for external robotic systems in their operation, which of course is the role we want to play with commercial space station operators. The business model was kind of fun, putting the band back together to some extent from the International Space Station perspective, to have an American company and a Japanese company and a European company and a Canadian company to kind of re-represent that collaboration we've seen for the last 25 years through corporate entities. So it was a little fun to be able to take the role that we seek as we put the band back together.
Excellent. Thank you so much, Mike. And we'll talk more about those business models and some of those approaches as we continue the conversation. And then also we have David Barnhart. Dave is currently CEO and co-founder of Arkisys. He's a research professor in the Department of Astronautical Engineering at USC and the director, co-founder of the USC Space Engineering Research Center at the Information Sciences Institute. At Arkisys, he is leading a team to develop a unique scalable business platform called the Port, which he will talk to us in more detail later in the webcast. Before launching the startup, David served as Senior Space Project Manager at DARPA, pioneering cellular spacecraft morphology, satbotics, space robotics, and low-cost, high-volume manufacturing. David, it's great to have you here with us as our tech expert here. I gave a brief overview of Arkisys, but do you want to just give us an overview of what you've been doing lately, and how does Arkisys fit into this commercial space station market?
Yeah, no, I appreciate it. Thanks very much to be among the august company. I appreciate it, both inspired by Mike and Jeff for sure. So What's sort of interesting is that the functions associated with what we think of as the International Space Station, and it really follows along a bit with what Mike is talking about, is the idea that instead of just having humans be the only one to do the manipulations, the idea that robotics can now take that instead and take pieces of that and sort of execute it. So what we're really doing at Arkisys is we're trying to follow an analogy from the Earth, and in particular, we call our platforms port modules. And that's very specific because we want to see a thriving architecture where there's arrivals and departures, where cargo is loaded, where services are executed, and it really helped to grow not only individual organizations, academic institutes, companies, but individuals to get them into space in a way that we haven't done that previously. So our view is we love humans, absolutely, totally, but we are autonomous and focusing really on a robotic modular platform to, in many senses, take some of either the low-hanging fruit or some of the things that may be a bit too concerning for having humans on board and being able to do that off on a separate platform. And so that's in essence what our port modules are going to be doing.
Thank you so much, Dave. Great to have the three of you on. Thank you for being with us. Just once again, a reminder to our audience, if you have questions at any time, submit them to us through that Q&A, and I will ask those questions throughout the conversation. So let's just jump right into it, guys. I have the first part of this conversation. I just want to set the stage because I'm a commercial space station. That's where my career is focused. So I also have to learn a little bit about what's going on with these space stations. My first question is, the ISS, is set to retire in 2030, and back in 2020 that was a whole decade, but now we're like 6 years away. So we have 6 years left before we find ourselves in this post-ISS world. As things stand right now, are we on track for a seamless transition to a post-ISS world? Will these commercially produced space stations and platforms be ready on time? And Jeff, I'll throw that one over to you first.
Okay.
Jeff.
Historically, it's a great question. Historically, the U.S. government has not handled transitions too well. And not only do we have the unfortunate situation of, the shuttle and the retirement of the shuttle and how long we were dependent on the Russians for astronauts, which of course would be impossible today. But even going further back in our history with shuttle being late, which is why Skylab came down and we lost our first space station. And there are a lot of examples in our history of not timing that well in the U.S. space program. I think now we're in pretty good shape. For something this complex, we've learned so many lessons. We've learned, to begin planning, not rely on any one team or company. And also the stakes are much higher now. Today we face a situation where we have the Chinese have their satellite, their space station in orbit, a heavenly palace. And that really raises the stakes. I mean, when we meet with people in Congress, we meet with administration figures, we say, do we want, and they say to us, do we want the Chinese to have the only space station in low Earth orbit? So I think the stakes are higher. We understand the importance from a commercial point of view, symbolical point of view. And so I'm more confident than I've been in the past about the transition.
Thanks, Jeff. Mike, do you agree with that statement? I mean, government doesn't have the same track record with transitions as maybe the commercial industry does. And are we on track for, when I say a seamless, like are both sides of the table moving at the same speed? And will we be ready for that world in 6 years?
It feels like it. I agree with Jeff's point, but the pressure's there. The drive is there to do it. I can use ourselves as a bit of example where I'm seeing like great support for transition. If you take us, for example, from an external robotics perspective, whereby, we just got our contract that extended. We just announced that the last quarter to provide continued robotic operations support to Canadarm2 on the International Space Station through 2030. So that's been put in place. That contract has the normal two roles that we would have had historically for that, which would have been, maintenance, repair, overhaul of the technology we provided, in addition to technical planning and real-time technical operations support to robotic operations by our engineers. Our teams have millions of hours of experience providing support to robotic operations on station over the last 25 years. So those two things were still there. But interestingly, we got a third thing added, which was for us to now to start to pick up the role of flight controller. So we will now have personnel who get certified as robotic operators on the International Space Station during its last 6 years as part of that transition. On the Canadarm3 contract we have, which is to provide the robotics for Gateway, the new space station that will orbit the moon. Again, we're delivering the robotic system, but we are also tagged to be able to operate that system for 15 to 20 years. And so we're able to get the support, picking up the flight controller role during Canadarm2, transition that into Canadarm3 for operations at the new station by the moon. And then we've co-invested in parallel to that to be able to have commercial derivatives in our SkyMaker product of the Canadarm3 product. And then we've invested in 3 mission control centers in a new facility in Toronto so that we're able to have those newly trained flight controllers be able to do that. So we're seeing the opportunity to work through the agency projects and the commercial projects in sync so that we can deliver the next generation of technology, do it in a commercial way, and upskill to the operator role in an organized fashion.
Excellent. David, as somebody from government, who has often been the interface with commercial industry, who's now with a startup who has to pitch a call to actions saying that we can do it faster. From your perspective, I mean, are we on track? What are your thoughts on this discussion?
Yeah, no. So it's interesting. Yes, I've had in the past been on the other side and sort of seen where some of the inefficiencies that Jeff referred to actually existed. What I think is really interesting in this particular domain and case is that there's a parallel activity occurring. First, you're having this conversation in the webinar today because, in essence, NASA actually asked for help and then funded several companies specifically to look at the replacement for the ISS. So that was actually good, right? That's proscribed thinking that they're thinking ahead. But the other thing that's happened is that the technology has advanced itself to the point where again, functions that occurred on the International Space Station that were centered around manipulation, energy associated by individuals and humans that are doing things, have now the ability to be done externally and or robotically, and the technology has advanced itself. As it turns out, the Space Force has invested a huge amount of money into this domain, which typically is called servicing, in-space servicing, right? And so that not just our company, but several other companies are looking at and developing the capabilities to do functions that, again, are analogous to some of the lower other or not the required ones that need humans in order to do things in space. And so from that standpoint, being ready now is a little bit different because you actually have a larger playing field that actually is moving into this direction, which I think is really, really exciting and informative for us.
Absolutely. Jeff, you mentioned the space shuttle when in your answer, and I think the space shuttle is maybe a good example of the consequences of not being ready for a transition. After the retirement of the space shuttle, we had to rent seats on the Soyuz to get to the ISS. You mentioned Heavenly Palace, China's space station. What are the consequences of us not being ready for the ISS retirement?
Well, I'll start by saying when I entered the industry so long ago, as I understood the situation, I was terribly embarrassed that the United States of America was relying on one vehicle, one program to get astronauts and cargo to and from low Earth orbit. It just seemed like somehow it was wrong. And so one of the things we've learned is that single point dependency. We saw it in low Earth orbit in our area of space stations. NASA learned it with the commercial cargo program, selecting what was then Orbital Sciences and SpaceX, learned it with Crew. with Boeing and SpaceX again. And so I think first off, we believe with Starlab that there will be more than one selection by NASA. There'll be two teams that go all the way to operational status, because we've learned the importance. And then to finally get to the point of your question, this time space is just far too important. The ecosystem that we've developed in low Earth orbit, because of the public-private partnerships that exist with the stability of the International Space Station. When we started NanoRacks 14 years ago, we were the first company in the world to own, operate, and market our own hardware. And younger people in the industry can't believe that. I mean, and look what we've accomplished in that time period. So today we have a robust ecosystem. We're not talking about one program. We have all sorts of services, all sorts of new companies that have developed, and that would be at risk prestige if China and their ally Russia have the only platforms in low Earth orbit. So it's really changed from the shuttle era.
So Mike, are we at the point where, if we don't make this transition, we're basically destroying a lot of capital investment and time? Or what are some of the consequences here of us lagging behind?
I think, it might destroy a bit, but I think there's also like losing position. Like, I think that the global demand is dramatically increasing. People are getting very comfortable, like not millions of people, but hundreds of groups are getting very comfortable doing things in space. And as the cost of launch continues to decline, the pent-up demand to want to go and do things is there. People are realizing, I'm sure we'll talk about the applications and the things you can do on a commercial space station as we go through this discussion, but that list is growing and people want to go and engage in those things as corporations. Wealthy people are learning that there's a bit of a tourism aspect that they're willing to engage in. Multiple countries now. If you just look at the Artemis Accords, you've got 42 countries kind of lined up with the United States. You got 11 countries lined up with China. So people are organizing themselves to go and do things in space. If we don't keep pace, I think that the demand and the commercial access of this, it'll just get sorted out some other way. And so I think it is, it's a global competitive position that we're establishing here that's important. And the consequences of not keeping pace is it'll happen some other way.
Mm-hmm. And Dave, before I get your thoughts on this, just one more reminder to our audience. If you have questions, please submit those. Like we'll answer your questions. We're talking just now about basic timelines. Like, what if we don't meet them? Are we generally ready as an industry? David, what are your thoughts here? We've got different timelines here. We've got different design approaches here. Like, what are the consequences in your mind of not being ready?
The interesting thing is that I think we're sort of at an inflection point, and the inflection point that I see is the only sustainable element that has been in space to date has been the International Space Station. It has lasted because it was designed to at least support that. But everything else that goes into space, 99%, has a shelf life, and it will eventually die. There's almost no way that a civilization can take that next step without truly moving away from what I'll call the throwaway culture that we exhibit for spacecraft today, as opposed to everything else on Earth that has the ability to be re-innovated, to be maintained, to be repaired, to be refueled, et cetera. There's almost no way that we can sort of grow. So from my standpoint, if we lose that opportunity to other groups, other countries, that is a huge sort of impediment to our future if we're not the ones that are sort of driving that and truly making sustainability the next step from an economic standpoint.
Okay, and Dave, sticking with you here, just setting the stage here, thinking positively. Like, let's say we are ready. Let's say everything works out smoothly. What are we getting that's better, right? What are some of the functions that were previously executed on ISS? What can be offloaded to these other platforms, and what are we getting that's better than what we had before?
Yeah, so let's see. From my standpoint, what I see is I've been pushing this for quite some time, is the idea to look at spacecraft a little bit differently than what we have in the past. Instead of them being monolithic, and they were designed for a very specific reason. Our launch was restricted. There was no way to repair, to maintain, to change any space system once it got to orbit. I get it. It's totally fair. That's the thing that we can essentially change. And if we have that capability, I don't want to say it's if we build it, they will come. But if we have the ability to build or grow or modify things after launch, that may well change the entire culture and the view of how designers on the ground will create new space systems. They already have to do that to some extent when they go inside the space station, because you can think that way. You can think that astronauts are able to add things after the fact. Well, what can you do if you now have either autonomous or robotic stations or platforms that are at different locations to be able to take advantage of? So that to me is the sort of the most exciting thing that I think we'll be able to get to.
Excellent. Mike, starting with Starlab, and Jeff, I'll get your thoughts on this too. Like, what does Starlab bring to the table that we didn't have before, and what are some of the functions that we can offload from ISS?
When I look at all the stations, there's the same good categories of things, right? We can, through all these stations, we can offer astronaut flights, we can offer the external science, the internal science in station, the external science. I think both the internal science and external science over time can turn into manufacturing inside or outside of a station, depending on what corporations or governments are interested in. Obviously, there's the tourism thing that's there. But when you think about these things, to me, like one of the biggest benefits to me compared to like the space agency sort of managed ones is the commercial model. So we end up with this entirely new agility based on a commercial model in terms of like what to do with the station. That's not based on a committee of 6 governments. It's a corporation that can do things, and if the demand's there, they can build another one or build a third or build one that's focused on industrialization robotically or another one that's focused on tourism or whatever. There's agility there that people can respond to, and so there's an expansion capacity that comes with the commercial model as people can engage, which and then is enabled by the speed of evolution of these things. So, we've lived this life of 25 now being extended to 30 years of a very large space station run by, largely 6 governments working together. We've seen that model, but the commercial model now, from an agility, expansion, and speed perspective, provides a tremendous opportunity for the future.
So Jeff, Mike talks about the benefit of just the commercial business model being applied to space station construction based on demand and the flexibility and agility that comes with. But what about some capabilities? Like what are we getting that's new that's going to be exciting?
Right, but before we leave that, let me just really hammer home what Mike's saying. By now we understand, don't we, that the commercial model works better than government operations. Let me just say it again and say it one more time. Okay, so just some specifics for what Mike was saying. The ISS was and is beautiful. It took us further than the space shuttle. You had much longer time. You had cargo resupply. You had ample crew. Several problems. You had problems with intellectual property rights. It's a major issue on the ISS when biopharmaceutical companies want to do private research. It's a gray area, and they don't want to spend tens of millions of dollars in research when there's a gray area on IP rights. And also, as Mike said, I always say, what's worse than having to do research or operations on a government-owned facility? Try one that's multiple governments. So at NanoRacks, we developed the skill set of working with the Japanese Space Agency, the Russian Space Agency, the American Space Agency, the Canadian Space Agency, which we've tried to take those lessons on to Starlab, which is probably the reason why we're the most international in our business model. But as we look at Starlab, we do see the era coming. One of the most exciting things for me, two points that we're really making with Starlab. The first is the equipment, the hardware on the ISS is old now. when you look at some of the, the hardware, the modules were built in the late 80s, early 90s. The hardware, some of it, the research modules were mid 90s. That's 30 years ago. And you don't have laboratories on the ground that have, research units that are 20 years old, 10 years, 5 years old. So one of the things I'm excited about having this new era of commercial space stations that has circa 2024 hardware and advances in miniaturization, robotics, and all the other advances that we see in our laboratories here on the ground. And that mindset will continue. No doubt, there'll be new generation hardware going up, 3 years after operations. You just keep going, because that's what you do in a commercial scenario. And we're seeing that we're right on the cusp of some of these things that research we've always wanted with in-space additive manufacturing, making of parts. Some of the things we're doing with eye parts and the corona, the eye, is amazing. We're seeing in AgTech, we're beginning to get very interesting advances that will help us here on the Earth, as well as we move on into the lunar and Mars settlements one day. And so it's not so much offloading, but I think it's more that the ecosystem will continue. There'll be advances made. The hardware will be state of the art. There'll be a commercial environment. And finally, we should see reap the rewards that we have wanted, NASA has wanted, the space agencies have wanted for several decades of true, genuine breakthroughs in research and in-space manufacturing. So I think that's what we get with commercial platforms.
Excellent. Before we go into the specifics of some of those applications and the different space stations we have a couple of questions here from the audience just giving about the overview we've provided. The first question is asking about some of the cost benefits here. So the part of the cost for many spacecraft is paying for the reliability, because you can't do the repair work in space. So are you speaking to new design, construction, standardization that when in-space repair becomes possible, we've already had the designs in space and the replacement hardware on the ground? David, you want to take a shot at that?
One of the big challenges to make something repairable is that you have to have a way to connect into its nerve system, into the mechanical system, into a fluid system, whatever that is. That typically, as we've defined it, is called an interface. So one of the things that are coming out just because of the functions required for servicing in general are new interfaces, and those interfaces now allow connectivity inside typically a monolithic platform. So I've looked at all kinds of different types of heterogeneous and homogeneous type of systems in the past. There's not one that solves everything, but I think what we're going to be developing related to replacements or repair are going to be easier ways to connect things to an object that has been in descended space after launch that provides an augmentation to a function which may actually be something that either failed on the inside or it's adding to it. And that's been done for quite some time on the International Space Station. Now it's potentially translating down into space platforms themselves. So that's really what sort of talking about. The question becomes, will we ever get to the USB in space, right? And there's a lot of companies that are really trying to do that. That's what's really interesting is that's something where the commercial market is the one that can flush that out the fastest, honestly. So,
and when you say USB in space, so like the plug and play,
yes, where you literally connect anything together and it understands what it is. Yes, yeah.
No, good analogy. It's really one of the most longest lasting, durable standardizations in technology history, right? So, Mike, do you have anything to add to that? Jeff,
I just wanted to comment that I agree with about the plug and play part of it. Like for us, we've had our robotic interfaces, which are used for external payloads and their connectivity to space stations now, in 2 of the commercial space stations. So, that's nice to be able to see that kind of thinking is there. And then the ability to use external robotics for, maintenance and extension and management of stations over time is important.
And if I can answer it from a different angle, one of the advantages we have at Voyager and at Starlab, at Voyager, we acquired Zinn Technologies, which has been working on the ISS since the onset, and NanoRacks last 10, 12 years. And we have Airbus as a partner. So we bring this ISS expertise and lessons learned. And one of the ways that we learned to reduce the cost of repairs, the need for repairs, is to reduce the complexity of some of the systems. So, for example, at Starlab, we envision almost no need for a routine, quote unquote, spacewalk, EVA. All the components are going to be able to be modified from the inside. We're not going to have to do a spacewalk to fix an antenna or do this sort of, that sort of repair. So we're also single launch. To op status, which is amazing. It's it's because of the Starship, and I understand will be the heaviest payload ever launched by humanity. And so again, that's to reduce the amount of launches, the complexity of integration in orbit, and so we're looking at it from what have we learned from the ISS that will reduce the cost of operations, and when you do have to make a repair, it's more robotic and not as human dependent, especially with EVA. So we're taking a slightly different view of that.
Okay, thank you so much, Jeff. The other question here from the audience is autonomy. We've hinted at autonomy, manufacturing, industrial R&D, space tourism. What will it take to oversee the infrastructure supporting all that? And Mike, as a manufacturer, what do you think they mean by oversee? Like what will it take to oversee the infrastructure?
I'm not sure. I guess that could come from a couple of perspectives. One would be like to oversee the technologies, in which case we're all, of course, following our normal, space engineering, design, and production and quality processes, which is governed, by the corporations that are developing these things. The other thing would be to oversee operations, I'm sure. In terms of, us all ensuring we have very experienced operational teams that are providing oversight and management to these commercial space stations. That's what comes to mind to me, anyway.
Okay. Dave, Jeff, any other thoughts on that? Quick.
Yeah, real quick. That's where I would sort of bring up the public-private consortium that was started by DARPA a couple of years ago. It's called CONFERS, which is now fully industrial member supported, and it came into existence for a couple of reasons. The primary reason was that to enable the in-space servicing market and understand that there probably needs some sort of standardization, regulations, guidelines, norms for reaching out and touching in space. So that's basically rendezvous and proximity operations. So I mean, in honesty, there was also a recognition that we really don't want the government to come back in and drive all of that when truly the industry is the one that has the expertise in that. And so that's part of what's driving CONFERS. So I don't want to say that's oversee. That's really sort of industry managing itself, trying to get out front and be really good students for what they're doing in space.
Yeah, agree with that.
Absolutely. Okay, so let's get into timelines now. We've got a couple people asking about it, and that's where we're going to head next. And obviously, we have Starlab representation on the webcast, but I do want to say, we did reach out to Blue Origin and Axiom to participate in the discussion. We couldn't make schedules work. So before we jump into those questions about what are the schedules for everything, I'll read this very quickly. So Blue Origin has the Orbital Reef station. They were one of the NASA award winners here in December 2021. They're designing their station to support 10 people with 830 cubic meters of volume. The space station is projected to be operational by 2027. That was updated as of a year or two ago. They've got partners including Amazon, Sierra Space, Mitsubishi, Boeing, Redwire, Genesis Engineering, and Arizona State University. Just a couple months ago, NASA confirmed, that Blue Origin completed testing milestones for its critical life support system as part of the agency's efforts for new destinations in low Earth orbit. And then we also have Axiom orbital segment, or the HAB-1 it's a planned modular system, so building components on top of one another. It's from Texas-based Axiom Space. They plan to build at least 4 Axiom modules, which will attach to the ISS. The first module is scheduled to be launched in late 2026. It would dock with the forward port of the ISS module Harmony. And they've contracted with MDA Space to manufacture and test the primary structure and the micrometeoroid debris and protection system for both the AXH1 and AXH2, which are expected to launch in late 2026 and 2027, respectively. So just want to give those timelines here. Jeff, do you want to walk us through the timeline for Starlab?
Yeah, I'd be delighted to, and I'll take it. I won't get into the weeds as much as that, but I'll say first off, to start, our business model, as Mike has alluded to, I like to get the band back together again. So first off, our business model is unique among all the teams in that we wanted to replicate the ISS partnership without, of course, Russia. I think that's one of the greatest successes of the International Space Station is showing the international cooperation that's possible. So now we have Airbus from Germany, we have Mitsubishi Corporation for Japan. Of course, we have MDA for Canada, and we have Voyager ourselves for the United States. We also are unique in that, as I just mentioned, it's a single launch to operational status. Again, we did that because we're taking advantage of the extraordinary Starship weight. And it also allowed something else, which is pretty cool. I mean, I'm never going to get into too much of a technical discussion with Mike and Dave here. You know, I can't hold my own on that. But what's very cool about Starlab is it's made of stainless steel, and it's Airbus is manufacturing it in a shipping yard, and we're able to do this. It saves us extraordinarily on cost. It saves us on time. It's 3 years of manufacturing, and we're able to do that because it's not the exotic materials. It's not composites or fiber. It's good old steel, and it's heavy. But Starship is also steel, and it can take on this lifting power. So that's another advantage that we bring. In terms of timelines, we're right on time. We're looking at late 28, early 29. It's going very well in the NASA reviews, and we expect to have all systems are working fine as we move to the design phase. We will be announcing more strategic and equity partners in the coming months, and there's a feeling that space stations for me and for Voyager and Starlab, they're not launch vehicles. They really are extensions of society. It's a lot different than a launch vehicle. And so we're really delighted at the partners that we have representing different countries and ones we're in discussions with now. So we're looking at late 28, early 29 with a really exquisite business model that should give and is giving comfort to the space agencies. I'll say one other thing. One of the challenges we all face, all the teams, is that the space agencies, non-NASA's, non-U.S. space agencies do not want to work with American companies. Canadian Space Agency doesn't really want to sit down with Voyager. JAXA does not want to sit down with Axiom or Voyager or VAST or anybody. And so one of the other reasons for this business model is that under our business model, JAXA will work with Mitsubishi, and Canadian Space Agency will work with MDA, and so on. And so we see this as a way of getting around the problem that astronauts are key to our business model. By the way, our business model is not tourist-based. It's more professional astronauts. And space agencies are using public funding, and they don't really want to say, hey, we just paid tens of millions of dollars to an American company. So our business model allows a very elegant way for that Japanese and European or one day Australian, public money can be, spent in country and shared by the joint venture. So that's where we are, and we're feeling pretty confident at this point.
Mike, I mean, I know we're talking about comparisons here before we kind of go further into that. We're not talking about this as like it's not going to be a winner take all situation, right? Like is there room enough for like all of these different, is there enough demand to support all of these platforms?
It would appear to be in the conversations for sure. Like for our example, like in terms of using our Skymaker robotics and the operations of those robotics, that gives us a conduit to talk to all the commercial space station teams and initiatives, in addition to other folks that are looking at having commercial on-orbit activity. As Jeffrey said, we want to create lanes of delivering that technology out to multiple parties in this market to be able to enable things. And so, it definitely appears that, things are going to move along. They're going to move along at pace, and that there's going to be, a good range of opportunity. When you look at like the number of countries that would want to engage to have just astronaut flights alone, Jeffrey mentioned that it's not all about astronauts everywhere, but professional astronauts in countries that want to have an astronaut corps are dramatically increasing. And they haven't had access to a space program because it's been tied up a little bit in these 6 countries that have had an international space station. And so, that demand is there, and that will span multiple opportunities for sales. From anything I've seen, I'm not at the front lines of this, but anything that I've seen, it would appear that that's the case. And then as you start to talk to corporations and the medical community, the materials community, the chemical communities, there's a lot of interest in what happens in microgravity and what can happen. Jeffrey mentioned some of the cellular stuff that we're starting to see, happen. If we can build retina in space, meniscus in space, if you can start to do, 3-dimensional development of, cellular forms in space, you start to get into the human spare parts business. Like, as soon as some of those things are successful, like the demand is going to crank, because it's a unique opportunity now for cellular material and chemical science, not just for an experiment, but for manufacturing. So you get into some pretty significant, astronaut interest and corporate interest in these things.
David, from your perspective, what makes these 3 systems, and you can also talk about Arkisys too, because I know that you're bringing innovation through the building process. What makes the design approach, the deployment approach of these systems unique? Like, what is interesting to you, being outside of that, to see like what's going on here with these companies?
Yeah, no, I appreciate that. So what's really interesting is that just taking a step back, I've heard 2 specific, almost 180-degree approaches. One is Axiom is following a modular approach. So they have 4 modules they want to put together. They want to put up the first one. And Jeff has described his approach as a single launch, right? There are almost 2 different approaches. Which one is right? Which one is wrong? Not sure. Honestly, there's value proposition in both of them. I think, as Mike talked about, the appetite is going to only grow for the utility and usefulness that each one of these are going to be able to bring. The question always becomes, from a build standpoint, is that you've got to, you want to merge speed with sort of reliability and making sure that the thing works. That this is not, a CubeSat, right? This is something that really has to operate. It is a complex system or system of systems that has to go up. 2026, that's pretty sporty, I think, if you're going to put folks up there. So we'll see. I don't see one or the other necessarily having advantages or disadvantages. Each one's a bit different, and each one, through the design of each one, I think is going to provide different focus functions on what it can eventually succeed on.
We have a couple of questions from the audience, one for Jeff, one for Mike. Jeff, I'll start with yours, because you mentioned about, being the crew for these stations. What fraction of the time do you see commercial platforms being crewed? How important is autonomous operation?
Well, NASA is, it's a good question. NASA is really the initial customer here, as they like to say, one customer of many. And they've laid out pretty strong regulations that this is a, permanently crewed platform. And as everyone's saying here, Dave and Mike, the demand is quite high for that. So we envision to be continuously crewed, comfortable at 4 crew members occurs, and it can have, surges when there's docking and crew transfer. And I didn't mean at all to imply earlier that there's a scarcity of astronauts, Mike. I think I was talking about tourism. We're not focused on the tourist market because we can accommodate tourism, but we're really going all out here on advances in the research and meeting the demands of all these space agencies around the world. So we're continuously crewed.
Okay. And the question for you, Mike, here, it says, Mike, years of microgravity research have led to the assumption that advanced pharmaceuticals, advanced microchips, and even human organs could be produced in space due to the removal of the gravity component. Have large companies such as Lilly, NVIDIA, CRISPR, et cetera, expressed any interest in building prototype products on commercial space stations? Is there anything like that in the works?
I won't name any particular companies, but there definitely are companies in the commercial industry and in those sectors that are talking to commercial space stations. Yes.
Yes. Okay. Ditto on that. Yes.
Yeah.
Right. And then this question here, another one here. I'll throw this to you, Jeff. What do you see as NASA's role in the development process and in ongoing operations? So, I mean, I guess you can answer this directly since.
Yeah, I mean, we went through this with the Bishop airlock, and now it's on steroids with Starlab. I mean, NASA has learned a lot of lessons in the last few years. They've come in as giving funding to the different teams to allow us to develop and get the teams together. We at Starlab received the highest amount, now totaling $217 million. And then NASA becomes a customer. But we need the important decision is NASA willing to put their astronauts on a private space station? In that regard, we have to be certified by NASA. In that regard, they are there at every step to make sure that we're not compromising on safety, we're not compromising in materials, that they're comfortable, there's redundancies. And so NASA is there, consider it as a very interested potential customer. They've put some money in the game, and now they're going to make sure before they decide which one or two platforms goes forward, that they're completely comfortable with all our procedures. So the relationship is dynamic, it's interesting, it's evolved, and it was the same with commercial cargo. It evolved with commercial crew, and now we're seeing everybody doing the lessons learned here on commercial destinations.
Thanks, Jeff. We have some more audience questions. I want to try to get them in but we have like 10 minutes. I want to make sure I get as many of these in. We might be jumping over a little bit all over the place, but I want to make sure we address these. So one question here, and really we didn't answer it at the top, and I should have, and I actually don't really know the answer to this either, so it'll be interesting to see. I'll throw it to you, David, first. We'll go through the panel. How will the ISS be decommissioned? And then I would like to add to that, like, do you think, I mean, is there a possibility that like we get to 2030 and we might need another year or so? Like I was just always curious. I'm always suspect the deadlines, but David, I'll start with you.
Yeah, my gut says that it would make the most sense to sort of extend the life of it. The challenge, and I know Jeff knows this extremely well, the challenge with the space station is the ability to schedule, because when you're talking about crew, that actually drives things back by at least 6 months, 9 months, maybe even a year to make a plan ahead of time. So, but my gut says that yes, if we need more time, I think my hope is that NASA would be have enough forethought to say, hey, let's push that out for a year or two, assuming, of course, they can convince the Congress folks to provide the funding to support it, which.
Can I jump in? May I jump in very fast? And Mike, if you don't mind, there's a certain, and I say this nicely, Dave, we've known each other a long time. There's a hubris on the part of certain people that it's going to be up to us, Congress, as to when the life of the ISS comes to an end. We live in very perilous times. We have we're basically at war with one of our partners, and supply chains are very fragile right now. We saw Eric Berger's piece in the platform Ars Technica that the leak is there. It's not going away. So I'm I agree with what you said, Dave. Maybe, we have to make sure the commercial providers are there. I agree completely. At the same time, we have to even accelerate, because no one can say 100% that it's going to be a peaceful end of time for the ISS program. It's a very difficult time. So I just want to add my New York pessimism on certain things.
Appreciate it.
Do we ever actually answer how it specifically will be decommissioned? Like what is the process of that? Just so we put it out there for somebody who doesn't know.
I'll let any of you guys.
I have not seen that plan, so I'm not going to pontificate on that.
Yeah.
Yeah, uncertain. Yeah.
I mean, the Russians were supposed to deorbit. Now the United States has the task to do that. So it's not an easy process.
Yeah.
Next question here. How is security being in space being addressed? I guess we'll stick to specifically with hosting some of these applications on commercial platforms. Mike, do you want to start, or who wants to start with this one?
I don't mind talking a bit about it. I don't have the magic answer, but first thing is it's real. And so we've seen an increase in collaboration. If I take the analogy from the satellite industry, when was it? Last week, the week before, we just announced it just here in Canada as a small example, the development of a commercial integration cell within the Department of National Defense's Space Operational Headquarters. The United States has a similar thing. Other countries do as well, whereby the corporations that are operating commercial assets in space have representatives that live every day inside the defense headquarters to be able to coordinate military and commercial activity. That's for awareness in terms of what are we all doing, but it's also for our own security and protection of each other and all of us that are allied, to be able to make sure that we're aware of any threats, whether they be environmental, a piece of debris, or somebody's inappropriate or not friendly acts towards another entity. There's definitely a surge to increase the level of coordination between governments and commercial entities that are operating in space, and I think that'll only increase in importance as we move beyond satellites and have more industrial activity and more human activity in low Earth orbit.
Jeff, David, we could address. There's a couple aspects here. One, let's talk about just space security from a national security perspective. One of the questions I had was, Jeff, you alluded to we're in dangerous geopolitical times where we do not have good relations with Russia, which is one of our partners on the ISS. But the ISS overall is a symbol of this sort of international cooperation. Can commercial space station carry that sort of symbolic torch of cooperation and keep that going even when you have geopolitical tension on Earth?
Well, the ISS was nominated several times for a Peace Prize, a Nobel Peace Prize. And on the one hand, I wish it had been awarded such, because it's an extraordinary international project. But on the other hand, we kind of failed. We didn't keep the peace. Maybe that's a little too hard. I'm sure it was not in the planning of the Russians. They looked at Ukraine and deciding what to do and not to do. They didn't look at ISS. But you do look that both the United States and Russia and Europe and Canada and Japan have kept the door open for cooperation. So one of the advantages of our business model is that we do hope Starlab is a beacon for multinational cooperation, reminding us, I'm very worried we're entering just a totally protectionist period on all supply chains. I do believe in international cooperation. I've staked my career on it when it makes sense, when it's done for the right reasons. And so I'm hopeful, and all of us at Starlab are hopeful, that international cooperation remains a course of action and a pathway, and Starlab could indeed be a symbol for that.
Mm-hmm. I want to get a couple more questions here before we wrap up from the audience. Dave, I'll go to this. I'll shoot this one to you since you're the startup here. There's a lot of doubt about a scalable and viable LEO privatized ecosystem without continued government funding and seed money and the past year's contracted VC funds. What are your thoughts on this?
Yeah, that's a really good question. That I guess the question is, what's the threshold, right? How much is needed, and then what is the point that we say, hey, we don't need any more? I might argue that this is still substantially new. And what we're really talking about is laying the foundations of an infrastructure, completely changing. An ecosystem is really, thrives on things that exist and that can build off of. So as an example, take AWS. AWS is nothing more than Amazon providing a bunch of servers available to anybody to utilize it. So they don't have to go do it. That's great. That's a piece of infrastructure. They had to pay for it themselves. In our case, we're, in essence, you can think about it as a piece of infrastructure that we want to get up to then support the growth that goes forward. That still needs to be paid for. I mean, the reality is, space is still a bit expensive. You still got to have the cash to do that. So I'm not quite sure where we're at. I honestly think the amount of money that has been put into space, especially startup space systems all across the world, is enormous. In all honesty, the question becomes, though, it has to start making money. If it's going to be a commercial ecosystem, that means it has to generate cash. I honestly think we're going to be there within the next couple of years. The amount of interest, especially the sort of the Mike and Jeff talked about, from all of what I'll call non-traditional space companies, whether they're manufacturing, whether they're chemical, whether they're agricultural, that all see the value proposition of doing things in zero gravity, provides a really enticing next step in terms of where the revenue is going to come from. So I'm thinking it's a couple of years, but we still need those folks that provide the investments, and that's the VC and the government, which has been doing a great job.
Excellent. And we'll make this the last question here. And Mike, I'll shoot this to you first. Is there an explicit plan among the commercial providers to remain co-orbital with each other? Seems like it would be crazy to let your nodes drift apart if you're starting out in ISS orbit.
I think each station has its own concept of operations. Jeffrey could probably talk a bit better about that.
Yeah, Jeff?
Yeah, I published a piece a few months ago, in fact, calling on all nations, operators looking at space stations to come together in some sort of co-location in order to share resources, up mass, down mass. We chose the International Space Station orbit for political reasons, to involve the Russians. They couldn't come down to our lower orbit at the time because you have to go over China. And the United States didn't want to ask China permission for every overflight. And so the United States went up. It was an extraordinary move, up to 51.6. And so now I think we can do better. We can go lower, where you save on fuel. You save hundreds of millions of dollars over the life of a space station, low orbit, and share resources. So I think it's a great, one of those commercial sector ideas that just makes sense.
Thank you so much.
And Jeff, I might, what to me what's interesting is I might actually, I would look at it differently to say, being co-orbital with every single station or platform, yes, that'd be great, but a burgeoning ecosystem has the transport that is able to go between these. And so I think we want to enable them, right? Orbital
very quickly. I didn't mean physically located, so I'm glad you're saying that. Yeah. Okay. I meant they can be 1,000 meters apart, 2,000 meters apart. And India doesn't want to attach to Starlab. Okay. But they might want to be co-located so that their commercial their cargo could service us and them. Yeah. So I agree with you completely.
Perfect. Yeah, that's awesome.
Yeah.
Well, Mike, Jeff, Dave, thank you so much for joining us. And also thank you to our audience for being so engaged. Thank you so much for submitting so many questions. I'm glad we were able to answer those questions for you. That's the purpose of Future Space Economy is to educate you, the attendees. So I'm glad that we were able to answer so many questions. I know we didn't get to all of the questions here. If possible, we'll send those questions and see if some of our speakers can answer them for you offline. But thank you all for joining us, and thank you to once again to Kepler for sponsoring this webcast platform. My name is Jeffrey Hill, Executive Chair of the Satellite Show, executive editor of Via Satellite. On behalf of my team, we thank all of you, and we hope to join you, for you to join us for the next one, which I believe will be coming up in August, and we will post that up on the website soon. So thank you so much for everybody. Have a great day, and we'll see you for the next one.